This video is brought to you by Squarespace, an all-in-one platform for building your brand and growing your business online. And you have to see this. NASA unveiling a stunning new image of space. It is the first full-color image taken by the new James Webb Space Telescope. 6 months after the most powerful telescope ever made launched into space, Control Center for the team inside the Webb Space Telescope's flight control room is preparing to reveal what astronomers all over the world have been waiting for. The very first full-color images from the James Webb Space Telescope. The James Webb Space Telescope is offering a glimpse of galaxies far, far away. You're looking here at the very first picture from NASA's James Webb Space Telescope. NASA has released more photos from the world's most powerful telescope, revealing the deep secrets of space. I remember you saying this is kind of amazing that after you win the Nobel Prize. You thought that this mission was the most important thing to work on. Absolutely. It's the next question. After you know how it started, what happened then? And suddenly we now had the technology to do it. We didn't have 50 years ago. Didn't have the technology 25 years ago. Even when we started this, we had to invent things along the way. So, we did that. And here it is. In the summer of 2022, just weeks after the James Webb Space Telescope began returning its first scientific images, astronomers noticed something odd. Scattered across the deep fields were tiny, brilliant red points of light. Objects Hubble had never seen, and in theory shouldn't exist in such large numbers. They weren't galaxies as we knew them. They weren't stars. And one of them would later be named the Cliff. This strange thing has opened the door to something far stranger. One that leads to a radical new idea astronomers can no longer ignore. In astronomy, calling something very red means it emits most of its light in long wavelengths, especially in the infrared. And some of these little red dots emit much of their light beyond 10 microns, far beyond what Hubble's instruments could detect. JWST, however, was built for exactly this kind of light. Its infrared sensitivity is so high that it can see objects whose glow has been stretched by the expanding universe for billions of years. That's why these compact ultra-red dots suddenly appeared. They weren't new. JWST was simply the first telescope capable of noticing them. And so the attempts to explain the little red dots began. One idea was that these objects were galaxies filled with enormous numbers of stars so compact in dust and shrouded that they appeared extremely red. Think about the space around our sun. If you traveled a few light years in any direction, you'd still be mostly surrounded by empty space. But in these proposed galaxies, stars would be packed so tightly that neighbors would sit incredibly close, not light years apart. In a galaxy that dense, the night sky would glow constantly, filled with the light of thousands of nearby stars. This explanation, however, demanded impossibly large masses. Only a few 100 million years after the Big Bang, too early and too extreme, even for aggressive galaxy formation models, the galaxy theory began to strain under its own weight. And so astronomers looked elsewhere. Black holes. The competing theory claimed the dots were active galactic nuclei. Black holes feeding rapidly surrounded by hot accretion disks. If these black holes were heavily obscured by dust, they could appear red. But this explanation too met with contradictions. The spectral signatures didn't match known active galactic nuclei. The number of dots implied far more supermassive black holes in the early universe than what our theories suggest is possible. In short, both theories fell short and astronomers hit a roadblock. But then something remarkable happened in 2024. The RUBIES program, short for Red Unknown's Bright Infrared Extragalactic Survey, secured 60 hours of rare JWST observing time. Led by Anna de Graaf at the Max Planck Institute for Astronomy, the team collected spectra for 500 distant galaxies. Within that enormous data set, they identified 35 little red dots. But one of them stood out. Its light had traveled 11.9 billion years to reach us, meaning it existed when the universe was just a fraction of its current age. When they looked at its spectrum, they immediately knew something was wrong. Or rather, something extraordinary was at work. In the region where ultraviolet light should have been, there was instead a violent jump in brightness. A sudden, almost vertical rise in the spectrum. It's the kind of feature astronomers call the Balmer break, a sharp step created when hydrogen atoms absorb light at certain energies. But this break was sharper, steeper, and stronger than anything seen in a normal galaxy. It looked like falling off a cliff, so why not name it that? Now, the cliff didn't just challenge earlier explanations, it broke every one of them. As Anna de Graaf put it, the extreme properties of the cliff forced us to go back to the drawing board and come up with entirely new models. This wasn't a galaxy behaving strangely. This was something fundamentally new. Before that, let's quickly hear from today's sponsor, Squarespace, which offers the best tools for easy website design. With their AI-backed design intelligence, creating your unique digital identity is fun, effortless, and quick. Their website design system called Fluid Engine lets you customize every design detail with this extremely helpful drag-and-drop technology. Squarespace also has built-in analytics so that you can easily track who's coming across your new page. Check out Squarespace.com for a free trial, and when you're ready to launch, head to Squarespace.com territory to save 10% off your first purchase of a website or domain. Now, back to the topic. Astronomers soon realized that the cliff resembled the spectrum of one very hot star more than that of an entire galaxy. That surprising clue pointed toward a radical new idea, the black hole star. We have a black hole at the center, an accretion disk around it. But everything, the entire system, is wrapped in a fixed sphere of hydrogen gas. This is where the model becomes unusual. Instead of dust obscuring the black hole, this enormous hydrogen envelope absorbs and remits the energy, acting like a star's atmosphere. Except there is no nuclear fusion, massive turbulence, and gas that behaves nothing like a stable stellar surface. Yet the energy source, the accretion disk, heats the surrounding gas in a star-like way. The result, a spectrum that looks uncannily like a single very hot star, but magnified to galactic scales. This setup naturally produces a steep Balmer break, just like the one defining the cliff. The models aren't perfect, but they match better than any previous attempt. If black hole star objects exist, the cliff is likely the most extreme example, a cosmic enigma revealing a new class of early universe phenomena. And the black hole star idea doesn't solve just one mystery. It may solve another that has been troubling astronomers for years. Why are there so many enormous black holes so early in the universe? Webb has repeatedly found supermassive black holes less than 1 billion years after the Big Bang, far too early for standard growth models. But earlier theoretical work suggested that a black hole wrapped in dense gas like a black hole star could grow incredibly fast. If objects like the cliff were common, they may have acted as growth accelerators, allowing early black holes to balloon into giants long before galaxies fully formed. It's a bold idea, yes, but not an impossible one, and it could reshape our understanding of how our universe evolved. The Graphs team already has follow-up JWST observations scheduled for next year. They will revisit the cliff and observe other little red dots with even more precise instruments. These future studies will test whether black hole stars objects really exist or whether the cliff represents something even stranger. And when those new observations come in, we'll be right here to follow where the cliff leads next. So make sure you subscribe to Territory, because this is your space. Using the powerful James Webb Space Telescope, scientists at the University of Missouri looked deep into the universe and found something unexpected. 300 objects that are far brighter than they should be. Scientists are now calling these mysterious objects candidate galaxies, meaning they could be galaxies at the edge of time. If confirmed, that would challenge current ideas about how and when galaxies formed in the early universe. On top of that, these objects seem to have existed when the universe was only a few 100 million years old. But according to the standard model of cosmology, that shouldn't happen, because during this time, the first stars and galaxies were just beginning to take shape. Now, to identify each of the 300 early galaxy candidates, the scientists used a method called the dropout technique, which detects high redshift galaxies by looking for objects that appear in redder wavelengths but vanish in bluer ones. After spotting these objects, the next step is to check whether they could be at very high red shifts, meaning, could they be even farther away than we expect them to be? Because in the past, scientists often thought these extremely bright objects weren't early galaxies, but something else that mimicked them. The lead scientists of the discovery believe that even if only a few of these objects are confirmed to be in the early universe, they will force us to modify the existing theories of galaxy formation. So what could they be? The ultimate confirmation will come from spectroscopy, the most reliable method available. By separating light into its component wavelengths, much like a prism creating a rainbow, scientists can analyze a galaxy's distinctive signature. This will reveal crucial details about the objects that we are seeing. The implications are enormous. If these really are fully formed galaxies, then our theories about how matter comes together in the universe may need to be rewritten. If they're not, then we might be looking at a new phenomenon, one that played a key role in shaping the universe's earliest days. Up until 2022, the most distant galaxy we'd ever seen was GNZ11, spotted by the Hubble Space Telescope. It was a landmark discovery. Hubble, with its 2.44 m mirror and incredible optics, had taken us deep into space, but there was a limit to how far it could see. Then the James Webb Space Telescope was launched. Armed with a massive 6.5 m mirror and tuned to infrared, the exact kind of stretched ancient light that early galaxies emit, Webb didn't just continue Hubble's work, it crushed its records. In one of JWST's early campaigns, a galaxy named Jade's GSZ 140 was found. It held the record for the most distant confirmed galaxy, with a redshift of 1432. Redshift, in a nutshell, is how much the light from a galaxy has been stretched by the expansion of the universe. The higher the redshift, the older the light. Then came MOM Z14 with a redshift of 1444. It pushed our view even deeper into time. And it wasn't just the red shift that stunned scientists, it was what the galaxy actually looked like. This galaxy is tiny, about 500 light-year wide. For comparison, our Milky Way spans over 100,000 light-years. But MOM Z14 is also incredibly bright. Normally, galaxies this early in the universe should be faint and hard to detect. Not this one. MOM Z14 is bursting with newborn stars, a rapid-fire stellar nursery in the first few chapters of cosmic history. But one feature, or rather the absence of one, made it even stranger. There's no sign of a supermassive black hole. Most of the galaxies we've studied with intense star formation host a supermassive black hole at their center. These black holes are thought to play a key role in galaxy evolution, regulating star birth, shaping structure, and driving growth. But MOM Z14 doesn't. The mysteries don't stop there. When astronomers used JWST spectrograph to analyze the galaxy's light, they found it rich in nitrogen. Unusually rich. This chemical fingerprint matches what we see in some of the oldest star clusters orbiting the Milky Way, suggesting that MOM Z14 is forming stars in extremely dense environments. That's not what we expected. Galaxies this early in the universe should be chemically simple, mostly hydrogen and helium. But MOM Z14 is telling us that multiple generations of stars had already lived and died before it. That means galaxy evolution may have started much earlier than we thought. It raises a big question. How many more galaxies like MOM Z14 are out there? Before JWST, we thought galaxies this early would be incredibly rare, but now we found more than we ever expected. These ancient bright galaxies, sometimes called little red dots, are popping up across JWST's surveys, and astronomers now believe that MOM Z14 may be the record holder as of now. But it might not be for long. And that's where things get really exciting. The more we look, the more we find. And every discovery chips away at our assumptions. If galaxies like MOM Z14 existed in greater numbers, formed stars faster, and were chemically richer than we thought possible, what else are we missing? Does the galaxy challenge our cosmological models? In a word, yes. Our current understanding of galaxy formation says that these kinds of galaxies should be rare, slow-growing and simple. Z14 is none of those things. It's fast, bright, and chemically complex. It's not that our models are wrong, but they're incomplete. MOM Z14 is a clue that the early universe might have been far more active than we imagined. And this is just the beginning. Later this decade, the Nancy Grace Roman Space Telescope will join JWST in scanning the early universe. Roman will cover much larger areas of sky with incredible detail. Together, these telescopes could uncover hundreds, maybe thousands of galaxies like MOM Z14, each one a time capsule from an era we're only beginning to understand. But for now, MOM Z14 stands as a milestone, a flicker of light from when the universe was still finding its footing. But the more we probe JWST's findings, the more the universe defies expectations. Some scientists interpreting the data have proposed something bold, that our entire universe might exist inside a black hole. A new research has uncovered an intriguing mystery that the majority of galaxies appear to be rotating in the same direction. The lines formed by the peaks here allow us to identify the direction of the curve of the arms of the galaxies, and consequently their spin direction. This is significant, because in a truly random universe, galaxy rotation should be roughly evenly split between two directions. According to the study's authors, this unexpected finding, which contradicts existing cosmological models, may hint that our universe itself is inside a black hole. To understand this, we need to look at the physics of black holes. When matter collapses under gravity to form a black hole, it creates an event horizon, a boundary beyond which nothing can escape, not even light. Anything that crosses this boundary is forever lost to an outside observer. However, what happens inside the event horizon is still a mystery. This is where black hole cosmology comes in. Also known as swirled cosmology, it suggests that our observable universe might actually be the interior of a black hole within a larger parent universe. Now consider the Big Bang. The standard model tells us that the universe began as a singularity, a point of infinite density, just like the center of a black hole. If our universe is actually the interior of a black hole that formed in a larger parent universe, it would mean that the Big Bang was not an explosion in empty space, but rather the moment matter collapsed into a black hole, creating a new universe inside. This has another implication. Each and every black hole in our universe could be the doorway to another baby universe. This could also explain why the fundamental constants of nature appear fine, tuned for life, because black holes that create stable universes may be more likely to persist and reproduce through this process. The scientists believe that this idea could explain several cosmic mysteries. For example, black holes are known to have immense entropy, which corresponds to the vast amount of information contained in our universe. Another factor that could play a role in this scenario is torsion. In extended theories of general relativity such as Einstein-Cartan relativity, torsion is a property that accounts for the intrinsic spin of particles and can influence space-time curvature. Some theories suggest that this twisting effect of spacetime could generate a repulsive force at extremely high densities, potentially preventing singularities from forming. If true, this could mean that instead of collapsing into an infinitely small point, a black hole could experience a big bounce where the core rebounds and expands outward, potentially giving rise to a new universe inside. The scientists continued by adding that rapid recoil after such a big bounce could be what has led to our expanding universe, an event we now refer to as the Big Bang. Instead of a singularity exploding from nothing, it could have been a rebirth from the core of a black hole in a parent universe. This theory would drastically change our understanding of cosmic origins, suggesting that the cycle of universes is an ongoing self-replicating process. Another intriguing possibility is that the universe may have a preferred axis. Studies of large-scale cosmic structures suggest a certain alignment in the way galaxies are distributed and move rather than being entirely random. This so-called cosmic anisotropy challenges the widely accepted cosmological principle, which assumes the universe is isotropic and homogeneous on large scales. If the universe does have a preferred direction, it could point to unknown physics at play, possibly related to the way our universe formed inside a black hole or how fundamental forces interact on the grandest scales. Moreover, the existence of ancient massive galaxies so soon after the Big Bang challenges our understanding of cosmic evolution. But while the universe inside a black hole theory is tantalizing, there could also be a more pedestrian explanation for the unexpected observations. Maybe some earlier measurements of our universe are incorrect, especially the speed at which the Milky Way galaxy rotates. In any case, the universe is turning out to be far stranger than we ever imagined, and the uneven galactic rotations will likely prompt astrophysicists to reassess certain aspects of our understanding of the universe. What do you guys think?